Hello everyone, welcome back to my channel. In this video, we are going to discuss another important topic in SRE, which is on-call management and escalation policies. So let's start. First, let us discuss what this is and why it matters. So on-call management makes sure that someone is ready to fix the problems 24/7, like an emergency hotline for your systems. Now, what does the escalation policies mean? These are the rules that make sure an alert does not get ignored. If the first person can't fix it, higher levels are automatically alerted. Now, why this matters is customers expect the services to work. On-call plus escalations keep the downtime short and avoid the chaos. Now, coming to the key roles and who does what. First is on-call engineer. He is the first responder. He gets the alert, acknowledges it and does the first troubleshooting and mitigation. Secondary backup is second line. If primary does not respond or needs the help, then we can contact the secondary one. Senior or expert, L2 or L3, deeper technical knowledge for complex fixes, database or networking, etc. Then comes the incident commander, IC. This person coordinates the response for large incidents, keeps the people focused, and decides the communications. Next comes scribe or communicator. The person who writes the status updates, tracks the timelines, and notifies the stakeholders. Then comes the product or the business contact. This person informs the product or the leadership when user impact is high or PR or social media risk exists. Now let's discuss the on-call life cycle step by step. What actually happens? First is detection. Monitoring detects something goes wrong. Error rate spikes. For example, error rate spikes. Then comes alert triggers. System sends an alert to the on-call tool, pager duty or optionally. Then comes the notification. On-call gets page through phone or SMS, push or Slack. Then comes acknowledge. On-call confirms they saw it, prevents duplicate paging. If someone acknowledges it, then it doesn't page someone else. Then comes triage. Quickly check the severity. Is this breaking the site or a minor issue? Next comes mitigation. Apply a quick fix to reduce the user impact. Either reroute the traffic, restart the service, rollback deploy, anything. Then comes escalate. If not fixed within the timeout, the alert escalates to the next level automatically. Then comes restore and verify. Ensure service is back and monitor for recurrence. Then comes communicate. Status updates to stakeholders and public channels if needed. Then post incident. Write the post-mortem. Create action items to prevent repeats. Next, let us take a look at alerts, good versus bad, how to design them. For alerts, the goal should be it triggers only when the human action is needed. For good alerts, the point should be indicates the immediate user impact, for example, site down or payment failures. Contain the context, what failed, where it failed, first log lines, link to the dashboard or runbook. And it should have clear severity. Next comes the bad alerts. These are also known as noise. The point should be excessive. It's excessive, 1 alert per second. Then no context, just error occurred. Then trigger for known noisy short spikes. Like these are already known, but then trigger for known noisy short spikes. Now coming to how to set alerts, let's discuss the simple rules. First point is tie the alerts to SLOs or SLIs. If an SLO is 99.9% availability, then alert on error rates that threaten the SLO. Next is use aggregation windows to avoid flapping. Third point is use multi-condition alerts. Last point would be always include link to the dashboard, suggested next steps, and owner or team. Next, let's discuss severity levels. What each means and what to do. First is P1, critical. Service down or majority of users are affected. Immediate page. IC may be engaged. Pause releases. Fire drill. Next comes P2, high. Severity is high. Partial degradation. Some users affected. Page primary and notify the secondary. Fix ASAP. Next comes P3, medium severity. Non-urgent issues, minor errors, logs piling up, create tickets, no immediate page. Then comes P4, low or info. Informational, like deploy success or low severity warnings, logged in dashboard and no paging. Next is escalation policy, structure plus example. Now, what it does defines who to notify and after how long if issue remains unresolved. Now, this is a simple example. Let's look at it. Level 1, the role is on-call engineer. What action he should do when notified is acknowledge and triage, if not resolved in 10 minutes. Then second is primary or secondary engineer. What he does when notified is take over and deep dive, if not resolved in 15 minutes. Then third is team lead or SRE lead. What he does when notified is coordinate the cross team help, where if not resolved in 30 minutes. Then last comes the engineering manager or IC. What he does when notified is execute notifications, customer communications, if not resolved in 60 minutes. Tips for escalation policies are: keep the timeouts realistic, not too short. People need time to investigate. Then second is auto retry the pages and escalate if no acknowledgement. Do not escalate even if it's acknowledged. Then include the contact methods, how one should be contacted, through phone call or Slack, or how. That should be, the contact method should be included. Coming to runbooks or playbooks, that's your cheat sheet during the incidents. Runbook is equal to step-by-step instructions for common incidents. It should be short, tested and easy to follow. Let's look at a runbook template, which is short. Now, title is website 500 errors. Symptoms: large increase in HTTP 5xx, checkout fails. First checks: open the dashboard, check the error rate or latency. Check recent deploys, the last 30 minutes deploys. Check DB connection pool, CPU and memory. Next comes the mitigation steps. If new deploy, roll back to previous stable release. If DB saturated, temporarily reduce the traffic, circuit break. Restart the pool, scale the DB read replicas. Notify product or legal if orders affected. Next is escalation. If not fixed in 15 minutes, call the senior DB engineer. Post-incident should be record the timeline, screenshots and create the post-mortem. Important is to keep the runbooks concise. It should be only 3 to 8 steps. Include the commands or links which are useful and mark who owns them. Now let's see the communication during incidents, what to say and when to say. Principles is: be timely, accurate and calm. Use a single main channel, Slack incident channel for example, Slack incident channel for updates. Let's look at an example. Initial incident message, for example, is incident, let's say P1, checkout failures detected. Time 11:12 a.m. IST. Impact 30% of checkout requests failing. See the dashboard link. On call, let's say RIA, acknowledged. Next update 11:25 a.m. Runbook, link is provided. Next is status update cadence. P1 every 10 to 15 minutes until resolved. P2 every 20 to 30 minutes. P3 at resolution or end of the day. For external communications, if customer facing impact, like if it impacts the customers, like orders lost or data issues, then write a brief external status page message. What happened, who is affected, what are the next steps and ETA. For handoffs and rotations, avoid surprises. Handoffs when shift ends. Outgoing on-call must brief the incoming on the following topics: current incidents and status, actions taken and next steps, and link to the dashboards and runbooks. A handoff checklist should include: are all the incidents acknowledged, are any action items pending, any scheduled maintenance windows, any contact details updated. Coming to rotation models. First is weekly or daily rotations. This is very common. Each person takes their fixed shifts, for example, week on and week off type. Then follow the sun. That's teams in different time zones cover daytime, reduces the night shifts for any one team. Then comes the primary or secondary. Primary gets paged, secondary only if primary does not respond. Best practices: keep the rotation short enough to avoid burnout. 1 week is common, avoid months. Now let's look at the tools used. First is PagerDuty or OpsGenie or VictorOps. These are alerting and escalations engine. Then for monitoring, Prometheus, Datadog, New Relic, Metrics and Alerts. For logging, Splunk, ELK for log analysis. Then chat and communications, Slack or Teams, incident channel and updates. Then ticketing is Jira and ServiceNow. Coming to training, drills and readiness. On-call onboarding, new people run through sample incidents and runbooks with a mentor. For fire drills and game days, simulated incidents to practice escalations, runbooks and communications. Runbook tests: periodically execute the runbook steps in a controlled environment and validate that they work. Now, metrics to measure the on-call health. First is MTTA, mean time to acknowledge. How long before someone acknowledges the alert? Then we have MTTR, mean time to recovery. How long it takes to restore the service. Then number of pages per engineer or per week. High the numbers, burnout risk. Higher is the burnout risk. Then repeat incidents. Incidents poor root cause elimination indicates the poor root cause elimination. If there are repeated incidents, then root cause has not been eliminated. Then we have percentage of noise alerts that were non-actionable. Then the aim is to actually reduce the MTTR and noise and not just the pages. Now coming to the post incident, the important cleanup. First point is write a blameless postmortem. The timeline, root cause, actions, owners. Focus on the systems and not the people. Do not blame anyone. Then create and track action items in Jira or Asana until it's complete. Update the runbooks based on what worked and what didn't work. Share the learnings with other teams to avoid the same problem across services. Let's look at a concrete example step by step. Let's say we have a food delivering app. Scenario is at 11 p.m. the food delivery app's checkout fails. Payment requests timeout. The payment doesn't happen. It goes to timeout and then the checkout fails. So first detect, monitoring shows 40% payment failures. Then comes alert. PagerDuty pages the on-call. Let's say on-call is Asha. The name is Asha. Then acknowledge. The next step would be acknowledge. Asha accepts the alert at 11:02 p.m. Now first checks for 2 minutes. Check the payment gateway error logs. Check recent deploys. Nothing. Then confirm DB and queue health. Next comes the mitigation attempt. 5 to 10 minutes. Restart the payment service container. No effect. Check third-party payment provider status page. Shows the outages. So next we'll move to escalation. Then escalation happens at 11:15 p.m. Escalates to the senior engineer, let's say Vikram, because issue is external provider. Then mitigation and workaround at 11:20 p.m. Vikram switches to a backup payment provider via a pre-tested fallback path. This is a runbook step, let's say. Then restoration happens at 11:28 p.m. Payments begin to succeed. Monitoring shows failure rate down to normal. Now coming to communication, incident channel updates posted every 10 minutes. External status page updated. Payments affected between 11 to 11:28 p.m. Fallback used, no customer funds lost. Next comes the post incident. That happens the next day. Postmortem created with timeline, root cause, the third party outage plus missing alert for provider health, then lessons learned, action items, implement automatic failover test, feedback to vendor, etc. and owners assigned.